Okay, want to touch base again on confidence intervals to estimate a proportion. So we're looking at one sample Z intervals to estimate a population proportion. So here's your scenario. Researchers at and this also helps answer some questions about other applications that people were asking about. Researchers at a large health maintenance organization are planning a study of a certain mild illness. They will select a random sample of patients who are ages 35 to 54 and see if they contract the illness in the next year. The researchers are interested in estimating the proportions of men and women who are likely to develop the illness in each of four age groups: 35 to 39, 40 to 44, 45 to 49, and 50 to 54. The researchers plan to include 2,000 patients in the study. Suppose the researchers draw a random sample from all of the patients at this HMO who are ages 35 to 54 and find the following numbers within each gender and age group. So they took a random sample of 2,000 total people. This is the distribution of what they found. These are the numbers of people who fit the category. So we see, for example, that there are 150 males that are between the ages of 45 and 49. So this is kind of like looking back at what we learned earlier in the two-way table where we have two variables, age group and gender. So we want to learn something about each of these age groups and the associated gender and what their proportion or likelihood right here. This is important. They want to estimate the proportions of men and women who are likely to develop that illness. Okay, because if you're talking about an organization, a health organization, you want to know these things. How likely is it that a group of people with these certain characteristics contract this disease or have this illness? So this is something important. So here's our question. Suppose that at the end of the study, they found right here 10% of the females in the 40 to 44 age group uh, contracted the illness. Okay, so they looked at this group right here, 40 to 44, in particular. They looked at that group of 370 females, ages 40 to 44. And we found in our sample, so this 10%, the sample of these 370 women, they found 10% of these people, so that's actually 37 of those, to have contracted the illness. So the question is, calculate a 95% confidence interval to estimate the population proportion of females in this age group that contracted the illness. So we have a sample. We know that 10% of these females contracted the illness. What we're trying to do is learn something about the entire population. The entire population is all of the females ages 40 to 44 in this HMO, this health maintenance organization, that they could have sampled from. So we're trying to learn from that. So calculated 95% confidence interval, and then we're going to interpret the confidence level too. So what's our confidence level? For a 95% confidence interval, we find p hat plus or minus. Okay, what's our z-score for 95%? So if you think of the normal distribution, that z-score is 2. So this is 2 times the square root of, we know p hat, 1 minus p hat, over the square root of all over n is all in the square root. So what's our statistics? We know from, okay, p hat is our sample proportion. Okay, we know 10%. We know that's 10%. So we can convert that to 0.10. What is our sample size? Okay, our sample size is 370. It's not 2,000. It's the 370 people that meet our criteria. So in other words, these 370 females ages 40 to 44. So our confidence interval should be 0.10 plus or minus 2 times this whole thing. So 0.10 times 1 minus 0.10. So 1 minus 0.10 is 0.90 over 370. So let's go calculate this thing. So this is going to be 0.10. Let's get our margin of error, 0.10. That is our point estimate. right? Point estimate. We need our margin of error. So if I go to the calculator, we can calculate the margin of error. That is 2 times the square root of 0.1 times 0.9 divided by 370. So that is a 0.031 margin of error. So we'll say 0.03. So that's a 3% margin of error. So this interval, what's this look like? That means take 0.1, subtract 0.3, so that would be 0.07, and then 0.1 add 0.3, so 0.13. Okay, that's our confidence interval. That's it right there. That's our 95% confidence interval. So let's do our interpretation. So our interpretation, what do we say? We are 95% confident. What are they trying to estimate? They're trying to estimate the population proportion of females in this age group. We're 95% confident that the population proportion of females, let's be a little bit more specific, ages 40, was it 40 to 44? Population proportion of females ages 40 to 44 that contract the illness is between 0.07, which we can understand as what, 7%, right? And 0.13, which is 13%. So we are 95% confident that of all of the females in this 40 to 44 age group, that between 7 and 13% of them actually contract the illness. So that's our interpretation. So now it says, without directly calculating the interval, explain how a 99% confidence interval would be similar yet different from the 95% confidence interval. So let's talk about what that would be. So how would it be similar but yet different? Let's start with the similar part. So how do you construct that? So a 99% confidence interval, 99% confidence interval would look like this: p hat plus or minus. Okay, what's the z-score for 99%? 2.58. It's one of the ones I gave you. Times the square root of p hat 1 minus p hat over n. Okay, that would be our formula for the 99% confidence. Now we're not going to calculate it, but what does that tell you? So first of all, how would it be similar? Similarity because p hat, like in this problem that we just did, which was 0.10, is still the point estimate and used in the margin of error, right? I mean, you're still going to use the same number. So that's similar. P hat is still the margin of error. It's the center of the interval. The difference is, okay, one way to say it is your z-score would be 2.58, which is not 2. But what does that mean? Overall, this is the most important part. This is a wider interval because we have increased the confidence. So if you're more confident, that means you have a larger margin for error and you have more wiggle room. So higher confidence means wider interval. And we could see that from the numbers. 2.58 is bigger than 2, so you're just going to make your margin of error a little bit bigger. So you have a larger margin of error is what happens when you increase your confidence level. You want to give yourself more wiggle room. If you're going to be more confident, got to have more wiggle room. Okay, describe how the margin of error would change if the number of females in the 40 to 44 age group increased. So if I take, so this is saying, what if we have more than 370 females ages 40 to 44? That's what we want to know. What's going to happen? Well, if you have, this means you have a larger sample size. So what if you had a larger sample size? If you took a larger sample size, what would be the effect on the margin of error? Well, if you take a larger sample size, you know more about, this means you have more info about the population. So if you have more information about something, that means your margin of error should decrease because you would be more certain. So overall, a larger sample size means the margin of error decreases because we have more information about the population. If you look at the formulas, if you take if I make this number bigger right here, your sample size n, mathematically, if I put a bigger number here and you divide by a bigger number, if you divide, let's say you take 50 divided by 2 versus 50 divided by 5, 50 divided by 2 is 25, 50 divided by 5 is 10. When you divide by larger numbers, you decrease the result. So putting a larger number in your denominator here would decrease your margin of error mathematically. Logically, it's because you have more information about the population. That means your margin of error should go down, and we should feel a little bit better about our estimates. So this was our little review video for some of the confidence interval stuff. So if you have any questions, again, please let me know. I hope you are all doing well.